Welcome back. In this video series by Sagar Kadam Sir Engineering Academy that guaranteed you will clear this very difficult concept of mechanics as without any doubt. And under this video we are going to discuss next theory part of impact. So impact numericals are solved using two equations, two formulas. One is law of conservation of momentum that we discussed in last video, and another one is a coefficient of restitution. It is not derivation like law of conservation of momentum, simply it is a definition. So during impact what happens? These bodies come in contact with each other. They exert very large force on each other. Due to that large force, they undergoes deformation. And due to elastic property, they recover from deformation and start moving with different velocities. So in this time of impact in which they come in contact and separate, we say that is a time of impact. So that time of impact consists of two times. It consists of two times, or we divide that time of impact in two times. One is a time of maximum deformation. One is a time of maximum deformation. So it is measured from the instant of just contact to the instant of maximum deformation. Under the action of these two forces, FAFB, body undergoes maximum deformation. So that time period is called as time of maximum deformation, in which these bodies undergoes deformation. Is it clear? A time from instant of maximum deformation, a time from instant of initial contact, just contact, to the time of maximum deformation, we say it is a time of maximum deformation in which body undergoes deformation. And another time, a time measured from maximum deformation to just separation, it is called as time of restitution. It is called as time of restitution because in this time these bodies recovered due to their elastic properties, their original shape and size. Bodies undergoes deformation. So from that deformation, these bodies regain their original shape and size. That time is called as time of restitution. Understood? So there are two times: time of maximum deformation in which these bodies undergoes deformation, and time of restitution in which body recover from deformation. Clear? Getting everyone? So what is coefficient of restitution? So coefficient of restitution is simply ratio of impulse during time of restitution to the impulse during time of maximum deformation. By definition, it is simply ratio of impulse during time of maximum deformation to the impulse during time of maximum deformation. One more time I am saying, coefficient of restitution is a ratio of impulse during time of restitution to the impulse during time of maximum deformation. And another way to remember or write formula is coefficient of restitution is it is simply a ratio of relative velocity of separation to the relative velocity of approach. Means what? Relative velocity means what? V2 is velocity of B and V1 is velocity of A. But when we take difference of these two velocities, what we get? A relative velocity. So this is a relative velocity of separation. And how much relative velocity of approach? U1 minus U2. You have to write this way. Cross is same. 2 minus 1 divided by 1 minus 2. If you can write like this also, V1 minus V2, then it is cross same, therefore U2 minus U1. Got it? Understood what I am saying? So this is called as coefficient of restitution. As using law of conservation of momentum and using coefficient of restitution, we are going to solve numericals. Okay? But while solving numericals, yes, there are three types of impact that we are going to deal with, of which number one is perfectly elastic impact. Number one is perfectly elastic impact. So what is perfectly elastic impact? As during perfectly elastic impact, this body, as we know that during impact body undergoes deformation. Body undergoes deformation. But in perfectly elastic impact, these bodies recover 100% from the deformation. Recover 100% from deformation means there is no loss in kinetic energy. Delta K is 0. Delta K is what? 0. No loss in kinetic energy. Understood? Because body is 100% recover from deformation. Relative velocity of separation V2 minus V1 is equal to approach U1 minus U2. Then what is its effect on E? As E is ratio of these two and they are same, therefore E is equal to how much? 1, for which perfectly elastic impact. For perfectly elastic impact, E is equal to what? 1. Got it? As in which body 100% recover from deformation. There is no loss at all. Got it? Is it clear? Okay. Yes, when they ask numerical on perfectly elastic impact, they never provide value of E. Yes, you have understood E how much? 1. Then number 2 is partially elastic impact, in which there is some loss. In which there is some loss. And how that loss is measured? Delta K 1/2 M1 U1 square plus M2 U2 square, it is a kinetic energy before, minus half M1 V1 square plus M2 is V2 square. There is loss in kinetic energy and that loss is calculated by this expression. Understood? Is it clear? So loss in relative velocity also. Therefore V2 minus V1 is less than U1 minus U2. U1 minus U2. So what is its effect on E value? It is a division of smaller divided by greater. Therefore E value is less than 1 but greater than what? 0. As for partial elastic impact, E value in between 0 to 1, and to solve numerical they provide value of E 0.5, 0.8, 0.7 like this. Understood? In partial elastic impact there is some loss of what? There is some loss of kinetic energy. Some loss is there and that will be measured in terms of kinetic energy. And for that E value in between 0 to 1. And last part is plastic impact. Plastic impact. So in plastic impact what happen? After impact both bodies moves with same velocity. After impact, here V1, V2 are the velocity after impact. So this body couples together and moving together after impact. Means V1 is equal to V2, that we take as V. In plastic impact, after impact both bodies moves with same velocity. Is it clear? That impact is called as plastic impact. On that we are going to solve numericals. You are going to understand how they move with same velocity during that numericals. So what is the effect on V value of E? Coefficient of restitution. So V1 minus V2 how much? 0. Therefore for plastic impact E is equal to how much? 0. E is equal to 0. We are unable to use formula of E for plastic impact numerical. Got it? Getting everyone? And as law of conservation of momentum, M1 U1 plus M2 U2, and after impact they are moving with same velocity, M1 plus M2 into V. m1 plus m2 into what? V. Got it? And how kinetic energy measured? 1/2 m1 u1 square plus m2 u2 square, it is the kinetic energy before, minus half, it is m1 plus m2 into v square. This is a way to find out kinetic energy as during plastic impact, loss in kinetic energy during plastic impact. So these are three types of impact to solve numericals. For perfectly elastic impact, E equal to 1, there is delta K 0. For partially elastic impact, there is loss in kinetic energy and E between 0 to 1. And for plastic impact, after impact, both bodies move with same velocity E0, and problem solved using law of conservation of momentum only. So this is a theory of impact. Okay, so hope so you understood this theory. But if you understood, don't forget to like my videos and subscribe my channel. Thank you very much.